Hello students. Now, when you go out, you always look at the mirror whether you're looking good enough. You see your image in the mirror. Now, this image which you see is due to the light. Now, you take a mirror and take under sunlight and reflect in your room. You will create illumination. Now, why that illumination is created? Due to reflection of light. Your image in the mirror is due to reflection of light. Illumination is due to reflection of light. So, we are studying reflection of light. Light is very powerful. It's a radiation and it travels at a very high speed. So, during lightning, that light comes at very high speed because light travels very fast. It's radiation, it's an energy. It can travel through vacuum also. But in vacuum, you cannot see the light. You can see the light only when it is deflected by some particle. So you can see the day is bright in the atmosphere because there are dust particles which are deflecting the light and you can see bright day. At night there is no light. And in space, you cannot see light. It is all very dark because there are no particles to deflect. So let us study reflection of light. Due to reflection of light, you can see the image, you can see the illumination. Now, light is a form of energy that creates the sensation of vision. If there is no light in the room, even if mirror is there, you won't be able to see your image because it is the light. It is a form of energy that creates the sensation of vision. Vision is what you can see. It is due to the light. The light gets deflected on the mirror and therefore you can see your image. It is an electromagnetic wave. It's a wave, it's a radiation that does not need any material medium to travel. It can travel in vacuum also. But in vacuum you won't see light, but it is traveling. So it does not require material medium to travel. It can travel in vacuum also. So it can even travel through vacuum. Light is invisible in vacuum. In vacuum you cannot see the light. We can detect light only when it is deflected from its path by the particles of the material medium. In atmosphere, dust are the particles. The light gets deflected by the particle and therefore you can see bright sunlight throughout the day. Within the Earth's atmosphere, light is deflected in all directions by the air and the dust particles. It is the dust particles which illuminates. Due to deflection, light deflects on the dust particles and that leads to brightness of the day. In space, it is all dark because there is no dust particles to deflect the light. The light travels at a very high speed. It is 3 lakhs kilometers per second. You can imagine how fast it travels. The distance between the earth and the sun is 150 million kilometers. So much vast distance. But still, in how much time it reaches the light the earth gets from the sun. So how much time it takes for light to travel from the sun? It is just 8 minutes and 20 seconds. It comes on the earth. Life on earth is possible only due to the sunlight. So here it reaches in 8 minutes 20 seconds. So you have to remember the distance between sun and the earth is 150 million kilometers and sun takes just 8 minutes and 20 seconds to reach the earth. What is the speed of light? It is 3 lakh kilometer per second. 3 5 zeros added when it is in kilometers. When it is in meters, then 3 raised to 8, because 1 kilometer will have 1000 meters. Therefore, you have to remember these numbers. It will surely come for your exam. So this is in meters. The symbol is C for the light. Now 3 into 10 raised to 8. Here it is 3 lakh kilometer per second, which is 108,000,000 kilometer per hour. Now let us compare the speed of some things with light. It is very less. Light is very fast, very fast. Now you have heard about Usain Bolt, fastest man on the earth. What is his speed? 37 kilometers per hour. Cheetah is the fastest animal on the earth. His speed is 114 kilometers per hour. Now speed of the sound, 340 meters per second or 1225 kilometers per hour. NASA X-43A, that is the fastest unmanned craft. It is controlled with the remote. No man is there in that craft. What is its speed? 10461 kilometers per hour. Now speed of the earth around the sun, 1,000,000. 1 lakh 5 is 50, therefore 1 lakh kilometer per hour. So this is the comparison of the speed, but light travels at a great speed, that is 3 lakhs kilometer per second, or 3 into 10 raised to 8 meter per second. When a beam of light is focused on the plane mirror, it bounces in all directions. That is reflection of light. So, how much it is reflected depends upon the surface. If it is opaque and highly reflective surfaces, all the light will be reflected. But if it is plain, then all the light will be passed. There will be no reflection. So, when a beam of light is focused on a plane mirror, it bounces back and moves in different direction. The bouncing back of light after falling on the surface is called reflection of light. Highly reflective opaque material, most of the light is reflected back. Transparent material, most of the light is just passes through. Now you can see your image on a metallic surface which is polished. You can see your image on water also, but the clear image you can see only on the plane mirror. It's a flat surface made up of glass. It is coated with silver, and along with the silver coating, on it is the coating of the red oxide. The glass is the reflecting surface. The coating of the red oxide is the non-reflecting surface. So that is why we can see very clear image on the plane mirror. Now this spherical mirror is curved. You can see the image, but it is curved. Spherical mirror is curved. Now this is the reflecting surface of the plane mirror, and this is the non-reflecting surface of the plane mirror. So what happens? A ray, it strikes the reflecting surface. Now this is the ray PO. It travels PO to O. This is the point of incidence, and this is the incident ray. So it forms a ray. The ray it forms a ray PO. This ray is known as incident ray. It strikes the mirror at a point O. Now from this point, another ray is initiated, which is reflection of the first ones. That is known as the reflected ray. This ray bounces to form OQ. So this is the ray OQ, which is reflected ray. It's the reflection of PO. The OQ is reflection of PO. O. So this is incident ray which is striking, this is the reflection, this is the reflected ray, and this is the surface of the mirror. Now, if you draw a perpendicular from the point of incidence O, you draw a perpendicular line that is known as normal. You draw a line from the point of incidence O, that line is known as normal. Now, you make an angle. There's an angle which is made with the incident ray and the normal, that is the angle of incidence, that is I. Angle of incident which is made from the incident ray and the normal, this is I, that is the angle of incidence. Now the angle which is formed between this normal and the reflected ray is R. So you have to know what is incident ray, that the ray which strikes the reflecting surface is known as the incident ray, and the point at which it strikes is known as the point of incidence, and what bounces from this incident ray is the reflected ray. The line which is drawn perpendicular from the reflecting surface is known as normal. The angle which is formed by the incident ray and the normal is known as the angle of incidence. The angle which is formed by the reflected ray and the normal is known as the angle of reflection. Now there are two laws of reflection. Very simple. What you have to understand is the incident ray, the ray of reflection and the normal, they all lie in the same plane. So that is the first law. Incident, reflected, normal, they are in the same plane. That is the first law of reflection. Very simple. I hope you understand what is plane. This is one plane, another plane, another plane, another plane. So they'll be in one plane. You just remember this one plane, they are incident and this is reflected, this is normal. They are all in one plane. Now second law is also very simple. The angle of incidence and the angle of reflection is equal. Now by this law you can predict what will be the path of the reflected ray. Wherever, if it is incident, it will reflected will be in the same plane and the angle will be same. Angle of incident, angle of reflection will be same. So you know that it will follow which path. So path of the reflected ray of light can be easily predicted by the laws of reflection. Now, there are two types of reflection. One is regular reflection of light and the other is irregular reflection of light. What is regular? When the incident rays are parallel, they are parallel. The reflected rays are also parallel. You can see these are parallel. When the reflected rays are also parallel, then it is regular reflection of light. Now, when it is not parallel, you can see incident rays are parallel, but the reflected rays are not parallel, they are scattered. Then they are known as irregular reflection of light. They are also known as diffuse reflection. Now, this regular reflection happens on plain mirror, polished metal, water, and it produces glare. You can reflect the light over water or mirror and you will see the glare. Even during rainy season, the glare of light is irritating on the driver's eyes. So, this regular reflection produces glare, and it also helps the camera to have a perfect image. So this is the function of regular reflection. This is where it happens, regular reflection. So where irregular reflection happens, in the room there is diffuse light. You can see object because there is irregular reflection of light. So here you can see in baby water, walls, tree, everywhere you can see only because of irregular reflection of light. That is also known as diffused reflection. So wavy water, wall, tree, and it enables us to see the objects.